My dear colleagues, time is running out. The Empire is intensifying its attacks against our bases, and we are having great difficulty rescuing the survivors. We must admit we are struggling to organize ourselves, which is why the High Council of the Resistance is asking us to develop an information system that will help us to assemble rescue fleets with the ships we have at our disposal. And I'll explain you right now what is the main feature we need to develop here. So assuming we have 5 survivors to rescue, our new product should search for the ships we have in our inventory named Swappy. So Swappy is an existing web service developed with REST. And here we'll take a particular look to the passengers' capacity of these starships, because we want to filter out the ships that cannot transport any passengers, such as here the X-Wing. Then, on the eligible starships, we'll apply a really complex algorithm to assemble rescue fleets. And that algorithm will be based on AI. It means it will have more than 3 if statements in the code, which is the official marketing definition, right? So here, I will try to popularize this algorithm for you. So as you can see here, the Millennium Falcon can transport 6 passengers, which is enough for the 5 survivors we have. So it will be the only ship taking part of this rescue fleet mission. So we don't have time to lose, and we need to choose right now the architecture for this new product. And I'm suggesting to apply this classic layered architecture with a controller layer, depending on a service layer, depending on persistence layer. Who agree with me? Some people didn't take a look at the title of the talk. That was a trap, just to see if any Empire spies were hiding among the ranks. So although this architecture can be really helpful, it tends to age poorly with time, and I will explain you why. But first, I have to ask you one simple question. In that kind of architecture, where are we supposed to find the business logic? Service layer, yes. But I also heard something which is true. Everywhere. But why? Because this architecture has some flaws. It doesn't properly isolate one layer from the other, and with time you will find some business logic linking inside the controller, but as well inside your persistence layer. So in the persistence layer, it means that you will have inside your data access objects some business logic there, meaning it will be quite hard to write some unit tests there, as you may rely on some ORMs, such as Hibernate, or something like that, or even an external database, forcing you to do some integration tests. Furthermore, if you need to change your database technology, it's pretty likely that you will have to rewrite that part of the business logic as well. And even worse, the most wicked engineer of the Empire go as far as putting the business logic in stored procedures directly in the database. Can you imagine this nightmare? Yeah, I can see people having some post-traumatic stress with other symptoms, so you know what I mean. Don't do that. How do you test our procedures anyway? But the problem is not only related to business logic. We also have problems with technical concerns, because you might think that everything related to the database will be in the persistence layer, but since this is a simple cascading architecture, it will leak everywhere. I'm pretty sure you already have seen people doing some SQL requests in the controller itself. But is there any people that are not doing Java here? Yes, some of you. So it's mainly Java, but I will try to make sure it won't be really important if you don't know Java. But I just would like to show you one common Java project using Spring Boot. So we are inside a service layer. So this is a project I just picked randomly on GitHub. And as you can see, it's annotated with annotation @table, @entity, which are Hibernate annotations. So it is an ORM. So from the service layer, we are shaping a SQL database. You can also see that some of the properties here are annotated with a JSON property, which tells the controller how to serialize over the network as JSON this object. So from there, we are coupling everything, the service layer, the persistence, and the controller, all together. This is quite common in classic layered architecture. So once again, if you change your database technology, you're moving from SQL to NoSQL, it's pretty likely that you will have to rewrite that code, and as well the controller, but it's different concerns, right? So too many coupling. So the other problem is that when we are using frameworks, such as Spring Boot or Next.js, if you are doing JS, or Symfony for PHP, we tend to put it everywhere even in places where it shouldn't be. Because if you are coupling your business logic with your framework, and then you need to update that framework to a new version that has breaking changes, such as a minor version of Spring Boot, by the way, you will have functional regression. And here you can wonder, is that normal to have functional regression of business logic that should be only algorithm, right? That depends on my domain, business domain, when I'm updating my framework? No, it should not, because it makes your business logic less portable. An example of that, keep in mind that one day your backend will become legacy. And let's say 15 years ago, for people who were already a developer 15 years ago, you develop a backend using EGB. Okay, it's a pretty old Java framework, right? Let's say that backend is still working, it brings value to the customers. But now, as you know, EGB is no longer maintained. So you would like to migrate to a newer stack, such as Spring Boot or Quarkus if you are on Java. But would it be easy to take the working business logic from that EGB application and put it in Spring Boot, which is on the same language? Yes or no? People say yes. People didn't work with EGB, I think. No, because that business logic is EGB shaped. It will be the same thing if you're moving to Spring Boot to Quarkus. So here, too many coupling, right? So I forgot what I would like to say. Yeah. The thing is also here, since this is a simple cascading architecture, if you have any trouble in the persistence layer, such as a compilation error, the service layer will fall with it as well as the controller layer, so you will have some kind of chain reaction of errors. So with time, you will have many coupling with your classic layered architecture for this lack of isolation between the layers. That will bring a lot of fragility. So today, we'll see an alternative to the classic layered architecture, which is the hexagonal architecture, that has been coined by Alistair Cockburn in 2001, that will help you to better manage software complexity and technical depth. And we'll talk about those things a bit later. But I'll explain you what is hexagonal architecture. Just some people know already what is it. Yeah, a few of you. So I will do a little reminder. So in hexagonal architecture, we don't want the business logic to be everywhere, because this is the most important thing of your application. You want to sanctify it because this is actually what brings value to your users and actually what pays your salary. So we take all this business logic, we'll put it in a single place. That will be easier to write tests that has only one responsibility, functional tests. And that place, we'll call that the domain. And maybe now you have one simple question for me. Julien, what's the difference between that domain layer and that service layer we used to have? Can't you see it? Some people have it? No? Yeah? That's the name, obviously. No, in fact, there is something that we have to add more, because the service layer we used to have in classic layered architecture has two responsibilities. The business logic, saw that already, but also have to orchestrate deeper layers, technical layers of your application, such as the persistence or web service clients. And this is something we don't want in hexagonal architecture, because we want that business logic to last longer and not dependent on anything technical. So instead of having here the domain depending on the persistence layer, we'll do a little trick and we will invert that dependency in a way that this is the persistence layer that will depend on the domain. So the domain, that we also call an hexagon for whatever reason, and it's not really important, depends on nothing else than itself. So the business logic is sanctified since it doesn't depend on anything technical. And in the domain, to make sure that this business logic will last longer, we don't put any framework there. It's forbidden. The framework will be only for the outside in the infrastructure layers, meaning the technical layers. But you don't have to reinvent the wheel again. You can put libraries in domain, right? It's okay. But only if it's quite easy to get rid of these libraries if you need, without having to rewrite half of the domain. And here you have a better management of software complexity, because if you remember the theory, in the domain you have essential complexity, which means the reason for being of your application, which is basically your business logic. And outside we have the mandatory complexity, everything technical which are required to make that business logic happen. And keep in mind that if you are mixing those two, you're creating what we call accidental complexity, that sometimes you call that technical debt, because here you have too many coupling. So let's see how hexagonal architecture is working internally. You will see that in the domain, the hexagon, there is two subparts, two sublayers, API and SPI. API stands for Application Programming Interfaces. Those are a set of interfaces that help the outside of the domain to interact with it. It's basically made for a controller to be able to trigger the features of the domain. So these interfaces are the contract of your features, and it only depends on domain object. And this is quite important, because that way you will avoid having any technical contamination coming from the left side of the hexagon. So no technical type can enter it. So anything related to your framework, such as Spring Boot or Jackson, which is the way to help you to serialize in JSON your Java object, or even the representation of your REST resources remain in the controller only. The domain will be agnostic to all those things. Then it will be easier if you need to add another way to interact with your application over the network, such as here. If you need to add a RabbitMQ receiver, you only have to create that module and interact with the same interface without having to change the domain. But the domain will need some data from outside, right? So it defines also some other interfaces which are called service providing interfaces that will help the domain to interact with the technical part, the outside. So these interfaces defined by the domain also depends on domain objects. So it means that the SQL client here has to implement this interface by complying with this domain object to avoid any contamination that time from the right side. So anything related to SQL requests, your ORMs, entity managers, and stuff like that will remain here in the SQL client. So that will be easier if you need to change database technology and move to MongoDB, for example, which is document-shaped, without having to change the domain, because SQL-shaped classes are there, document classes are there. So this architecture, we call that also ports and adapters. The API, the SPI of the domain are the ports on which the technical layers can connect, and they are called adapters, those technical layers, because they are here to convert and adapt the external technical world, such as REST and SQL, into the inner world of the domain. But enough talking, let's do a little live code now. I will show you how to set up hexagonal architecture. So, is that big enough? Hope so, because this is quite big already. We are at the really beginning of the project, right? So for now, I only have one module, the domain. You have to know that in hexagonal architecture, we always start by writing the feature first, then we'll do the related controller, and then we'll do the persistence. Since I'm at the really beginning of the project, for now, I have no feature developed. I just would like to show you that here, my project, which is based on Maven, you can see its dependencies. It only depends on JUnit and AssetJ, and if you don't know Java, it's testing frameworks, so it's OK. I don't have any frameworks, such as here, Spring Boot. So it depends on nothing technical. In the domain, for now, I have defined my domain model. So I have a fleet, which is a record of a list of starships. And a starship is something that has a name as a string and a capacity as an integer. So capacity, remember, is the passenger's capacity. So now we have to write the feature, right? But hexagonal architecture is not only an architecture style. This is also a development process in which we'll shape the hexagon using some functional tests. So we'll do some acceptance test-driven development. And here I have a functional test that should assemble a fleet for 1,050 passengers. When I will call here the domain, I should retrieve a fleet. And in that fleet, I should have starships that have enough capacity altogether to transport all the passengers. And also would like to make sure that each of these starships has enough capacity, meaning more than 0. Remember, the X-wing, we don't want that. OK, so let's implement that. Here, I would like to interact with my domain that way, I would like my feature to look like assemble a fleet for passengers given a number of passengers. So assemble a fleet does not exist, so let's create that here. I need to give that a type because Java requires that. I will call that assemble a fleet. And for now, I will initiate that to null. So assemble a fleet does not exist. I will create that. And here, IntelliJ is asking me if I would like to create that as a class on interface. What should I use? Interface. Yes, because this is the contract to interact with the domain. So here, I'll put that in production code. And in which subpart of the domain should I put this interface? Remember, there's two. API or SPI? API, yes. Because this is the contract to enter the domain. If you don't like the name API, you can use instead features. It's exactly the same thing. So let's create that. And here you can see that now I have my API package in my domain with assemble a fleet contract, which is for now empty. We'll populate that from the usage there. OK. And now I have a for passengers method inside it. And as you can see, it only depends on domain objects, such as here the fleet, or basic types of Java to avoid any possible contamination from the outside of the domain. OK. So then if I want to execute that test, I need here to provide a concrete implementation of this contract that I will call fleet assembler. That will be the concrete implementation of the feature. So let's create that fleet assembler. So that time it will be a class, obviously, because it's an implementation. It has to comply with the assemble of fleet contract. So let's say we have to implement the for passenger method. And in this, I will add the business logic. As you can see, I'm coding really fast. I don't need AI. So this is called snippet, by the way. But anyway. And here you can see that the business logic is divided into two subparts. First, I would like to retrieve the starships from Swappy, the external inventory. And then here, I have the AI model that will select starships from the inventory and assemble a rescue fleet with it. OK, so let's implement all those things. So retrieving the starship from Swappy. If you remember, Swappy is a web service. So it means that if I want to call that here, I would need to write some HTTP clients and some REST API consumption. But here we are inside the domain, so we should not do that. This is purely technical. We want that domain, the business logic, to last long. And the thing is, if I'm moving from Swappy to something else, which is not using HTTP, or maybe it's a different REST API, I would need to change the domain, even though the business logic didn't change. So it means that I cannot call that here directly. And instead, what I will do, I will create an abstraction of what is a Starship inventory. And I would like it to have a Starships method that will help me to retrieve all the Starship at once. OK, so Starship's inventory does not exist. I'll create that here as a field. Let's give that a type, Starship inventory. And obviously, we need to create that. OK. So once again, class or interface. Interface. In which subpart of the domain should I put this interface? SPI. Yeah, you get it right. OK. So now I've created this Starship inventory in the SPI of the domain. So let's populate the content of it with from the usage there. And here, as you can see, the contract only depends on the starships of the domain to avoid any possible contamination from the right side that time. So we created the barriers around the domain. OK. So then here, I need to do a little trick, which is not really important, but important for the tests. Just a filter that gets rid of the starship that doesn't have enough capacity. And now the code you're all waiting for, the AI model. So I will show you, but don't be too hard with yourself. It's quite complicated, right? So you know what? You should take a look at it. I said, don't take a look at it. OK, I lied. There is no if statement there. It's not AI. But I have a while, right, which is even better. So it's just naively taking one ship after the other until I have enough ship to transport everyone. But it's not really important. The aim here of that talk is to show you hexagonal architecture. So let's say the business logic is coded, right? But if I want to execute that test, I need then an instance of Starship inventory. But I cannot instantiate that from there because the real Starship inventory implementation will be technical. This is the Swappy client doing some HTTP. So I will do some here dependency injection, right, through the constructor. So someone else will give me one instance of that, and we'll see later how it works. But as you can see here, now I have one problem. I need to give in the tests an instance of the Starship inventory for the fleet assembler. And even in the test, you cannot rely on anything technical because the domain and its related test has to be agnostic from any technical part. So the only thing you can do here is to simulate what is a Starship inventory. And you do that quite easily with a stub. So what we'll do here, we'll inline a fact referential of starships with big and small starship. And I will simply pass that here as a Java lambda. So here, OK, you have your instance of Starship inventory. And even though this is fake data, I can execute here that test. Because the aim here is not to test the integration with the real Swappy client and the domain. It's just to test the business logic. It's only one purpose. And as you can see, this is working fine. The test is green. OK, so what we have seen so far. We've created a functional test that helps us to shape the contract of the domain. Here, assemble a fleet in the API part of the domain. This assemble a fleet depends only on fleet and starship to avoid any possible contamination from the left side. Assemble a fleet is implemented by the fleet assembler, which is the concrete implementation of the feature, which needs some starship from the outside. But since it cannot call directly the outside, which is technical, it defines its own contract Starship inventory here in the SPI of the domain that depends only on the Starship to avoid contamination from the right side. And because we want to execute that to make sure the business logic is working, we've created a step. OK, so the next step then, we've created the business logic, and we need to make sure it brings the value it's supposed to bring. So what we'll do, we will expose that over the network using a controller. OK, so I will show you that. OK, so I will do a little fast forward here because there is some boilerplate, but you will see that now I have a new module, infrastructure. And this module, I will put obviously any technical stuff. And as you will see here, it depends on Spring Boot, which is a structuring framework. But this is totally OK because Spring Boot is made to help us to manage mandatory complexity like Symfony, like Next.js, and like any other big frameworks like that. So basically, this is where I will put the controller. But it's not because I'm inside the technical layers that I won't start with a test. We'll do some integration test development. OK. And why we will do that? Because it will help us to shape the API, the REST contract API of the application. So here, I'm saying that this application should expect outside to be able to do a post on that rescue fleet URL. It should accept a JSON as a request in which I should have number of passengers. And for this particular test, I will pass 5 as a value. Here, as a result, I should have an HTTP status to create it to a 1. And I should also have one response, which is a JSON that should have an ID, which is the ID of the rescue fleet I just created, a list of starship inside that fleet. And for this example, I should have only one that should be the Millennium Falcon with a 6-passenger capacity. OK. OK, so let's create now the controller. So here, I just mapped that on rescue fleet URL, and this is the endpoint that will be called on the post. So here, basically, what should I do? I should call the domain, right? And we'll do that exactly the same way it has been made in the functional test, because the functional test takes exactly the same place than the controller. So we call assemble a fleet for passengers, given a number of passengers. So that number of passengers, we will retrieve that from the rescue fleet request here, that will be serialized by Spring using the @request_body annotation. And you will see it's inside it. So OK, let's get that, from there. Okay. So then here, assemble a fleet does not exist. So we create that as a field. And here, IntelliJ is asking me if I want to import that as a class on interface. So the concrete implementation or the contract. So on that side, and on that side only, if you don't like having too many interfaces inside your application, you can rely on the concrete implementation fleet assembler. But personally, I rather like to stay on the interface because that would be easier if I need to test the controller in isolation by stubbing the domain without having to rely on external mocking frameworks such as Mockito for Java, for example. But anyway, as you can see here, I have one compilation issue. And this is because the domain is returning a fleet while the controller expects me to return a response entity of that fleet. So if you don't know what is response entity, this is a Spring representation of what is an HTTP response, in which you can put the headers, the HTTP status, and the body of the response. So basically, this is technical. So this is something I don't want in the domain. So this is where the controller takes its job of an adapter, because you have to adapt the output of the domain here, which is a fleet, into a response entity of that fleet, which is in fact the HTTP response, right? So I'm using basically some Spring Boot factories to do that will initiate me an HTTP response to creating 201, and I'm simply passing the fleet as the body of the response. But if I want to be able, if I want that controller to work, here I need an instance of disassemble a fleet. So I will ask Spring to give me that by dependency injection. But as you can see here, it won't work because Spring doesn't know my fleet assembler, right? So usually you have to register everything you want Spring to inject in the other classes. So to do so, what do? Usually, so that part will be a bit Spring dependent, but it won't be long. So usually what do? You go inside the concrete implementation and you add that kind of annotation, right? Sorry, it's not this one. Add component, add service. But can I do it here? No, because this is Spring dependent and I will contaminate the domain then. So what people do usually to fix that problem, they go to the infrastructure, they create a configuration, and here they do some bin factories, and they instantiate themselves all the objects of the domain, and they register that in the Spring context using add bin here. But I don't like this option either, because it's like doing half of the job of the dependency injection framework. So I rather like to stay on the annotations because I find it a better user experience. But how can we do that since these annotations are Spring dependent? So I will show you a little trick, and that will be the only last thing about Spring, to make sure it's not your domain that will be aware about Spring, but the opposite. And that's quite easy to do. So you simply have to create your own annotation, such as here, in the domain service. Usually that annotation helps me to do some living documentation. If you don't know domain service, that comes from domain-driven design. It means features, if you want. And I will add something here, which is a retention policy to runtime, meaning that this annotation will stay at runtime. So the frameworks will be able to detect this annotation. And the next thing is quite easy. I simply have to annotate my class here with my custom annotation. And then I just have to make Spring aware about that, and that's quite easy to do. You go to one configuration, and here you had a component scan directive, and you set to Spring, scan for my custom annotation. Anything annotated with that, you load it inside your context. And then you will see that the controller here now no longer have any problems. Even IntelliJ will see that this is the fleet assembler that will be injected there. But still, I have one issue left. I need an instance of Starship inventory. So you have two options: creating the real Swappy client in the infrastructure, or you can do what I will do now. I will just stub it, and I will explain later why you can benefit from that. So a stub of Starship inventory, I had one already. It was inside the test, right? Here, the functional test. Remember, I just inlined before a referential, and now I wrap that in a class because it will be easier to reuse that in the production code. So that class Starship inventory here stub is inside the production code of the domain and has to comply with the Starship inventory contract. So it has to implement that Starship's method, and this is where you can find the inline referential. So I would like this to be used by the controller as well. So what I have to do, I just have to create my custom annotation at stub. Here, I'm annotating that with it. So remember, this is fake data for now. OK. Oh, I will, please, OK. And then I need to update the domain configuration to take this annotation into account. And you will see that now the controller is working pretty well. So do you have any idea why I put that stub in the production code? No? No more errors, but this is green, so this is working fine. So the reason why I put that in the production code is that now my application, I can run that and deploy it in a pre-production platform. And this is a technique I used while I was working at Expedia. We were working on a rail booking system that was really in bad shape. The backend was really a nightmare, and we decided to rewrite it from scratch. But unfortunately, the mobile teams already have planned to integrate these APIs. So in order to not putting too much delays in their plan, what we did is that we recoded the business logic, we exposed that in a controller with fake data, and they're really happy about that because they were able to learn about the domain, the workflows, they give us feedback without having to wait for us to integrate the real train inventory, which took us 1.5 months for the full team. So it's a better way to be more incremental in your development, and it's thanks to the Hexagonal architecture. But if you don't have that kind of needs, you can put the stub inside the test. You don't have to put that in the production code. OK, so what we have done so far, we have an integration test that helps us to shape the REST API of the controller, which is using the domain exactly the same way than the functional test. So the next step is to work on real data to get the Starship from Swappy. So we'll create here a Swappy client. First, I would like to show you what is Swappy. Swappy is an existing web service which is totally public. This is a referential on Starship things. On Star Wars things. And as you can see today, it's not working because they have a certificate date invalid problems. Okay? But it's not a problem for the rest of the talk, fortunately. So let's see how to integrate Swappy in the code. OK, so if you don't mind. So I have prepared a bit the thing as well, and now you will see that in the infrastructure, I have here a Swappy client. But before showing you the code of Swappy client, in fact that we will write, I would like to show you the test. Here you can see that when I will call the Starship method on that Swappy client, I would like to retrieve all these Starships. But as you know, this is an external web service, Swappy. And maybe you know that this is a bad practice to rely on external web service inside your CI/CD. Because if that web service is not responding or have a certificate error like today, your test won't work. So that's why here I've created a mock server, which is simulating my Swappy, the external web service. And I just reproduced the Swappy API there. So I should be able to do a get on the Starship endpoint of Swappy, and it should respond with success with a JSON with that Swappy page here. So I've made some extraction of the swappy JSON responses, and I would like to show you how the API of swappy is shaped. Because as you can see here, swappy is paginated. Something I didn't expect at the first time. So we'll see how we'll handle that pagination stuff. Then you can see that all the starships that are inside this results thing. So it seems that the API is a bit generic, but anyway. And there is a lot of data inside the starships. Here, I'm really interested about the name here and the passengers, which correspond to the passenger capacity. But there is something annoying here. I don't know if you can see that. This is a string. It's annoying, right? Because I need to sum these values. OK, so we'll see how we will handle that. So this is the implementation of the Swappy client, which has to comply with the Starship inventory of the SPI, right, contract. Obviously, since we are inside infrastructure, you can depend on framework. So here, this is annotated with Spring, so it's totally OK. But what you can see here is that this Starships method, the domain expects us to return all the Starship at once. It doesn't care about Swappy being paginated. So it means that we need to do it here. What is interesting with Hexagonal architecture is that you won't have any accidental choice that comes from your partners. Because usually in classic layered architecture, if your partner is paginated, usually your service layer will become paginated as well as your controller, even though you don't care about pagination. Here, I know that I will never return a lot of starships. And in these starships, I will have 2 fields, so I don't need to be paginated. So this is where that client will do the adaptation. So here we write for the paginated Swappy client. In fact, I will collecting page per page all the starships and return that to the domain. So the first thing I need to do then for the first page is to retrieve the starship from Swappy. OK, so I won't get too long on this one because that's quite easy to do. It's a simple REST template, HTTP client. I'm just doing a get on the next page URL and serialize the response in that Swappy response class. So the Swappy response class here is just a representation of the JSON in Java, and I just map the data I need. So here I have a next, which is the next page URL as a string, result, remember, which is the list of Swappy starships, and a Swappy starship subset that has a name as a string, and passengers as a string. But if you remember, in the domain, I'm expecting capacity as an integer here. So it means that the domain has made some choices, design choices. You know that it needs to sum these values. So it will be, it don't want to get some strings there because it's accidental complexity, right? How do I mean, why should I care about the fact that Swappy is returning a string? Because if I'm changing Swappy to something else which is returning a big decimal, should I change the domain because of that? No. This is the choice of the partner. So that's why it will be contained on the Swappy client only. It's not the matter of the domain. So that's why here we have a conversion to write. And that conversion will simply take each of the Swappy starships, convert that to the starship of the domain by passing as an integer the passenger's value here. And this is a complexity the domain doesn't have to handle. So now, if I'm going back to the test, it should write right. It should be OK, right? Let's see that. No, it's green. It's not green, sorry, it's red. Why? Because you see that sometimes I'm trying to pass NA as an integer value, which doesn't make sense. And why do we have that? You can see that in the extraction here of the Swappy response, as a passenger value, sometimes we have NA, and sometimes we have unknown. So it looks like there is a bad data consistency regarding Swappy. But also, if you move to the next page here, what do we have? We have 1,000 separator. It's annoying, right? Looks like Swappy was more made for a front end and not for a back end. So maybe it was a bad choice. But anyway, I have to integrate that. But thanks to the Hexagonal architecture, all this complexity will be inside the adapter only because this is related to swappy. The domain won't have to do some defensive code because it gets a string, so it has to, okay, is that empty? Is there any character I cannot convert in integer? That's not the aim of that business logic. That should be only on the technical part. So here, I will do it simply quickly. I'm just creating a filter that can get rid of all the starship that doesn't have a valid passenger value. What it means having a valid passenger value, it means you are not NA or known. And then I need to get rid of the 1000 separator. So my master gave me one simple way to do that, which is pretty neat. You simply have to replace all comma by empty string. So please don't do that in production, right? So maybe you guessed that my master ChatGPT, but I'm allowed to do that because I'm a professional prompt engineer, not you. Okay, so here, let's see if this is working now. Let's cross fingers. Is that green? Yes, this is green. So usually here, I'm restarting the application to show you that this is working well with the real swappy, but swappy has a certificate problem today. So what we have done so far, we've created a test to shape the swappy client, which has to comply with the Starship inventory contract. So it means that the domain has made some choices, design choices. I don't care about pagination, and I want integers. Okay, so swappy made some other choices. This is paginated as they have strings. So here we have a representation of swappy starship, and the swappy client has to adapt a swappy starship to the starship of the domain. But it's not only an adaptation. This is also what we call an anti-corruption layer. Why? Because everything entering the domain should be always valid. Because we don't want to do some defensive code. We don't want to have starship that doesn't have any passenger value because we don't care about the starship. So in fact, during that conversion, we will remove all data that doesn't have the consistency that the domain needs. So that's why this is an anti-corruption layer. So to finish, let's say that we push that in production. This is working well, but unfortunately, we forgot to make sure the ships have enough cargo capacity. So currently, the survivors, they have to leave behind them all the materials. So we did a little evolution, and now you will see that, is there not there already? Okay, it's coming. Yes. So now you will see that in the starships, they're there. I have now a cargo capacity as a big decimal. But I have capacity and cargo capacity. I don't like that. So here, I would like to rename that capacity to passengers capacity. It's less confusing, right? So let's do that refactoring. So do you know why I'm doing that refactoring at the end of that talk? Any idea? No? Because I can. No. Do you know what is the impact of that? I just broke my consumers. So from the domain, I broke my consumers. And why? I will show you that. Let's go back to the test of the controller here. We'll restart it. And you will see that it's no longer working. Let's see that. OK. So as you can see, the test is no longer passing. And it says it expects me to return a capacity in the JSON. But now I'm returning a passenger's capacity instead. And why? Because if I'm going back to the controller here, you will see that I'm returning the fleet from the domain. So if I change the domain, the REST API will change as well. So it means that I just coupled the consumers with my domain. And the worst part of it, it means that I need to do some REST versioning in the domain itself. A nightmare, right? And here, I've done a pretty common mistake. I didn't represent in the controller what is my REST resource. And because of that, I have that kind of coupling. So what was missing there is to represent, like I said, what is now a fleet resource. So a fleet resource belongs to the controller here, as you can see. And inside a fleet resource, we have a starship resource. And a starship resource is something that has a capacity, the old field I want to get rid of, but it stays there for backward compatibility, and a passenger's capacity, which is the new field. And here, I'm taking the domain object and I'm mapping twice the passenger's capacity, once in the old capacity of the Starship resource, and second time in the passenger's capacity of Starship resource. Now I can tell my consumers, you need to move from capacity to passenger capacity, and the domain is not contaminated by that. I have passenger's capacity and no capacity anymore. So in fact, here, by creating your resources, you create an anti-corruption layer that helps you to make your consumers decoupled from the domain. It will help also to have the REST versioning and REST deprecation only on the controller part and not in the domain. So that was all for me. You can scan that QR code if you want to have access to the code. Julien Topc, I'm a technical coach at Shodo, a consultancy company specialized in domain-driven design and software craftsmanship. And if you have any questions, don't hesitate to see me after the talk. Thank you very much.